Coming up on this episode of the IoT Inc. Business Show.
As you get closer to the edge, this is where the state of the art starts to come into play, because we've lived in this centralized world from the databases we've been talking about, and now processing is getting more distributed. So as you move out into the fog, the types of analytics that we see in the market today are things that are happening in more real time.
How much IoT data should you keep? It's not clear. The more data you keep, the more data transmission and storage costs you'll incur. However, thinning out your data store means throwing out potential future insights, potential answers to future questions, and potential new information products to expand your business, all value generators unique to IoT products. In this episode of the IoT Business Show, I speak with Steve Stover about balancing the costs and the technology approaches to maximize your Internet of Things data value.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 22 is Steve Stover. Steve is Senior Director of Product Management with Predixion Software, an advanced analytics company. Over the last 20 years, he's overseen the delivery of big data and analytics solutions at companies including Dell and Teradata. Steve, welcome.
Thank you, Bruce. Thanks for having me.
No, it's my pleasure. So big data, 20 years. How long has big data been called big data?
Well, actually, big data is a fairly recent terminology, but that's actually why Teradata actually came up with the name that they did, because they didn't think data would get bigger than terabytes, which they've been proven wrong.
Right.
But it's a recent phenomenon, but the concept of volumes and velocity of data are, been around for quite some time. Volume,
velocity, and veracity? Is that another one? Or
well, veracity would be 2. I guess that's an interpretation.
Yeah. Well, yeah, it's funny. I thought you were going to say, well, it's only been big data because before that it was medium data, and then before that it was little data. But I guess big changes over time. So what is big data then? What is considered big data, as in volumes of data nowadays, and specifically with respect to IoT?
Yeah, with IoT, it's really interesting. The IoT generating data is somewhat analogous to data that's from a Twitter stream. If you think about it, okay, data that's coming from a sensor, it's just basically chirping, and it's usually small messages. But the difference with the IoT, when you think about all the connected devices and all the sensors that are supporting that, you can have hundreds or thousands of devices that are chirping data. So that's really about the velocity of the data, and the volume of the data comes in the aggregate, right? So there's millions and millions of messages flying around in the IoT. So that ends up in a very highly cumulative effect in a very short amount of time with smaller types of messages. So it's a little bit different, but it's pretty analogous if you think about all the data flying around in Twitter.
Yeah, well, that's a lot of data. So what type of volume then are we? I mean, you've said, it could be coming from thousands of different sensors. In reality, in your experience in IoT, how many sensors I guess how many different data streams have you actually seen? What would be the biggest example?
Well, let me give a kind of a relatable example, because sometimes the big examples are hard to relate to, and then I'll just give a big one. In a small one, in a smart parking type example, There are sensors embedded in the pavement themselves, and then there are cameras that are taking a look and counting the vehicles and counting the duration that length that they're there. That can generate, that we've seen something to the tune of 70 kilobytes a minute. And if you think about that, 24 hours a day, that's huge volumes from one single parking lot.
And that's mostly the camera, or is it?
It's the sensor data and the camera. So the camera actually will reduce some of the data that's moved around because it's doing some local processing. But from the sensor and the camera and how that travels through the IoT architecture, 70K a minute is actually a lot. If you think about doing that citywide, so that's just one open air parking lot, not a parking deck, with a couple hundred spaces, and that's a tremendous amount of data. So 70K, that's megabytes and megabytes just on a daily basis for one parking lot. And municipalities are deploying solutions like this citywide, so it's easily terabytes of data per day.
Terabytes of data per day. Okay. And so then after a couple of days in Teradata, they have to change their name then, I suppose.
Well, we'll leave that up to them, but I think they might be a little attached to it.
All right, talk to us about a big example. I want to hear a big one.
Well, big examples this is interesting when we talk about, the enormous number of devices and the enormity of data. What's interesting, a lot of the data that's out on the edge doesn't move much further than the edge because of the very problem. So, a large example is something like a smart building in a skyscraper, and that's actually small. But if you think of a skyscraper, it has everything from, their security systems from cameras, door entryways, elevator operation system, HVAC on multiple floors, multiple temperature sensors on different floors for different tenants. We've had discussions with some of our customers where it can get to terabytes a minute, right, in the data that's flowing just to the example of a building. And if you think again about that on a bigger scale, I'm giving a couple of more public-oriented examples, but we see examples on large manufacturing lines where they're generating, again, literally terabytes within minutes or hours. So it's not unusual to see that kind of data volume. And there's a term that I like to use. It's kind of marketing-y, but there's really this data deluge, and those numbers give you an idea of why I use that term.
Yeah. All right. Well, you've impressed us. So now impress us with your background. Tell me a little bit about yourself and the background in IoT.
Sure. So at Predixion Software, one of the reasons that I joined this company was I've been in big data and analytics for quite some time. And the focus from an analytics perspective to really solve problems is really what drew me here. So we've been focusing on this space, and it is somewhat emerging as IoT has grown out of M to M. So now people have all this great data. They're moving beyond trying to connect it and collect it to do something with it. And it's a really unique opportunity. And what we're doing at Predixion is really interesting. At Dell, what I've worked on that is most relevant to IoT is we had Cloudera engineered solutions. So I worked with manufacturers who perform shop floor automation and optimization. So it was bringing all that sensor data in and a Hadoop cluster analyzing all of that data to make operational changes to ensure production capacity and uptime. And that's more recent history. But then years back, I cut my teeth at Teradata. In the early 2000s, I went to work for them in analytical CRM systems, and also just the general analytics set of solutions that operate on Teradata systems. So it's been an interesting journey for me for analytics, a long time before IoT was mentioned, and quite frankly, even big data. I've also worked on cloud solutions at companies like Dell and Quest Software, where this is all related, but spent a lot of my time in the analytics field. And then, like I said, working with manufacturing now with Predixion, working across a number of verticals to go make some value out of all this data.
Is there a kind of an equivalence? I mean, it sounds like you've been in, the big data, whatever it was called before, but you've been in the field for a while. Is there some equivalent to Moore's Law that you've seen in your time in big data? Like what are you doing more of now? And, what is it? What is the metric? What's the metric that measures the analytics that we're performing today? And and that metric, how is it changing over time?
Well, it's kind of interesting that the more quantifiable metric is the amount of data. Analytics,
just like, again, the total volume.
right? So analytics is a little bit more difficult to quantify. So there are market perspectives where there, just in the example of IoT, you can see market research examples where the compounded annual growth rate for just analytics within the IoT is going to be about 35% to 2020. And that's going to get to about $70 billion from.
Okay, so you're saying revenue from analytics products.
Yeah, all analytics products within the IoT.
Okay, 35% compounded growth. And what would you say the correlation between that and the growth of volume? What is the growth of the volume of the data? 35 is going to be, I would imagine, greater than 35% at a compounded rate?
It is. So just a couple of other data points. So research from Cisco says, and these are popular data points, right? We're go from 12 billion to 50 billion connected devices within the next few years up to 2020. IDC says the number or the bits of data is going to be something to the tune of 44,000 exabytes by 2020. And to put that in perspective, that often doesn't resonate because most of the average person doesn't talk in exabytes. That's 4,400 billion terabytes, just absurd amounts of data. So the growth rates are similar, but interestingly enough, it's a little bit different because the rate that data gets produced is not the same and is occurring at a higher rate than the revenue from analytics products, because if it went in line, that would mean the overall universe of spend on analytics products would just be completely out of hand. And it's up to us to innovate to figure out how to bring the cost of bringing value through analytics down, regardless of the growth rate of the data.
No. I would imagine if we did the math on it, then it's going to be, far north of 35%. But listen, you told us a little bit about yourself that we can read in your bio. Tell me about something about yourself that most people don't know.
Most people don't know is that I was an aspiring pool player in a competitive league in my late 20s. However, what you would also not know is you would not be able to tell if you saw me play pool today. I'm one of those people, it wasn't, I was relatively good, but it wasn't like I was LeBron James and picked up a pool cue when I was 5.
Right.
I played off and on, and I took a lot of practice to get reasonably good. But like I said, you couldn't tell it today.
Now, how come you let it go?
I got
not in bars as often, or what?
Well, that's part of it. No, it's just a function of getting very deep into my career and then family, and then things like pool leagues don't seem quite as important.
Yeah, I hear you. It just didn't. You can analyze it to make it make sense then for you.
There you go.
I guess, yeah. All right, well, let's transition into analytics. Why don't we start kind of at a high level? Describe an analytics system. What are the major components, and something that I guess what are the components that are common to all analytics systems? Because I know there's different types, and then maybe we can drill down from there. But just describe an analytics system for us.
Yeah, as you mentioned, analytics is a bit of a loaded term. It's kind of large, so it's always good to start at a high level. So one of the basic ways to talk about analytics are, chunking it up in the difference between, say, BI and reporting, which is usually looking at what happened in the past and kind of what's happening now. Mm-hmm. There's the concept of streaming analytics, which is applying rules to data for more of the here and now and looking and peeking into the future in small time windows. And then there is an area of advanced analytics that's really focused on predicting the probability of an event occurring in the future at some point in time, or the value of an attribute at some point in time. And that's three big buckets. The things they're common to all of those is there has to be a data source to analyze the data. Sometimes that data is coming from sensors. Sometimes that's living in a database and static data. In the case of IoT and industrial, you're going to have maintenance logs. But that has value in analyzing with the data that's coming from a sensor. So you can bring all of that together, oftentimes in some sort of centralized data store. And that's done with typical things like, ETL processes. But there's going to be some sort of input for the data. And then depending on the analytic system that you're taking a look at, like the categories that I mentioned, sometimes you're going to have cubes that are operating on large data warehouses. The other component is the streaming aspect. And then there's the data that you're actually analyzing. So there's the concepts of data in motion, which has become a really popular term because of the IoT, and data at rest, which is some of that static data. So there's always going to be some kind of data source. Oftentimes there's going to be a centralized store. And then of course there's the visualization aspect, because you want to solve some kind of problem. Sometimes that surfaces in a dashboard, sometimes that surfaces in an operational system, sometimes that surfaces in a business rule to perform some sort of action. So it's really the data that you're going to analyze, the user interface with which you interact with that data, and then take some sort of action. And that's at a very high level.
That's at a very high level. Okay, so the source, and then the centralized pool or repository in most cases, and then the visualization of that data. Now, is this generally all within the same package, or are you cobbling together different packages to do this?
It's often very distributed. So the raw data sources are always heterogeneous in nature. The data store, it's not unusual, going again back to, say, a Teradata or an Oracle. We all know those vendors in IBM that have a significant presence and a set of expertise in building more traditionally oriented data stores. So it is, and then there's the whole concept of data marts and data warehousing that still exists within the IoT. More recently, coinciding with the big data term, we were talking about before. Particularly within the IoT, Hadoop is making its presence very known, because it serves as a foundation for data lakes that are often housing a lot of this IoT data, because just to have a platform that's cost effective in dealing with the volumes and velocities. So there are components that are somewhat common at the storage or infrastructure layer. From an analytics system, sometimes it depends on what kind of problem you're trying to really solve. There are companies like a Tableau who focus on the visualization, right? There are companies who can claim to solve soup to nuts all of your problems, like a SAS or an IBM SPSS. But because of the diversity of the kinds of problems that are, the people in the market want to solve, there is usually a mix of tools from how you analyze that data relative to your objective and the problem you're trying to solve.
Okay, no, that makes sense. So if we look at it from a system point of view, so I have an IoT platform. Generally, I'm buying or renting it as opposed to making it. But let's say I have a platform. What are the requirements to actually run an analytics system?
Well, so let me talk about two different models. There's kind of the build it yourself, and when I say build it yourself, I mean house it yourself. So the interesting trend in the IoT is you're starting to see a lot of the cloud providers add a lot of infrastructure to take away the traditional operational burden. IoT is kind of interesting in that we've learned a lot of lessons that creating data warehouses and things like that are extremely expensive and time consuming. So wouldn't it be great if you could go to, a Microsoft Azure or, Google Compute Engine or an Amazon and build your application there and let them worry about storing all that, really all of that data that's often really expensive. So there's kind of that aspect, and we are seeing trends in the market where either SaaS-based companies are building that, and just because of the scope of what IoT can mean to some customers, they choose to go that route because it's a big initiative for them to bite off to get the kind of value that they're looking at. So you do have to take a look at the expense, and that can be very costly for IoT just because of the data volumes. You need to make sure you get the ROI based on the problems you're trying to solve and the numbers of users. So that's one aspect of it.
So just to clarify, you're saying to do it yourself or not do yourself, which is interesting because you're saying that has to do with basically housing the data. And if you do it yourself, you're talking about building your own warehousing infrastructure. And if you're not doing it yourself, that means you're using one of these larger cloud providers for the purpose of storage. Am I getting that right?
Right, from a core kind of application and storage platform perspective.
Okay.
Building out the hardware and software infrastructure to deal with the data.
And do people, in your experience, how many people are rolling their own as opposed to using one of these services? Or I guess depends on the situation, I suppose. But is this kind of a 50-50 or kind of a rarity?
I think the cloud portion is starting to emerge. So IoT is kind of the trendy name for what M2M evolved out of. So everywhere that there was M2M, that most normally, and that's been around for a while, SCADA systems have been around forever.
Sure.
And those are normally done on-prem, but they're siloed, rigid systems. So the need for openness is one of the things that's driving to cloud. But from my point of view, I see this transition where the cloud value proposition and time to value and not having to deal with the overhead and infrastructure and cost, that's catching on. But we're really at the early stages of that. But we're in this inflection point of the evolution of M2M to IoT, and that's coinciding with the rise of some of the applications being built on these cloud platforms, as well as specialty providers, like a Wind River with their Helix product, which is all about device management and bringing data in. It's still cloud-based, right? So there's kind of the do-it-yourself build on a cloud, and then building or having cloud-based services for this. So I think that'll be the trend, and SaaS is not a new thing, right? So it's interesting to see this trend now, and I think it accelerates faster than, for lack of a better term, SaaSifying other applications that have typically been there, like in the old days, the ERPs and the CRMs of the world.
No, definitely. Just with respect to our the previous thread in our conversation, with respect to the growth of the data and just being able to maintain or keeping on top of those costs, obviously centralizing those costs in one place would make the most cost-effective sense. In any case, all right. So we've got the housing of the data. What are some other requirements that we're looking for?
Sure. Then there's the requirements necessary for the analytics system that's going to be running on top of this stuff.
Yep.
And again, you can run many of those in the cloud. Some of them are optimized for on-prem. But when you talk about the volumes of data that we've been talking about, the way those products are normally priced, they can get pretty exorbitant pretty quickly, hundreds of thousands to millions of dollars. Depending on the type of problem you want to solve, you need the right hammer to hammer in the right kind of nail. But it can get very expensive very quickly in some of these massive deployments. Again, and that's part of the reason, that's one of the elements of why IoT deployments are focused on not moving as much of the data from the edge to a central location. It's not just the data transmission costs, it's the infrastructure and software costs and application costs associated with that much data.
Absolutely. Right. So you're saying basically, again, there's more of a trend to move to housing the analytics on the cloud just because the data is there anyway, or what are you saying?
So there is a trend to moving to the cloud. There are trends in the overall architecture in storing or aggregating or dealing with data at various points in an IoT architecture, be it or even close to the edge, or in some cases the device. But this gets into models like Cisco's fog computing model. That's part of their value proposition, is being able to distribute your computing and your capacity further out to the edge versus the data center. So you can distribute that out and perform things more locally. In the case of Cisco, not actually on the device, but as close to the device as you can push to the edge of the network. So we see a lot of trends like that. And a lot of that, again, has to do with moving as little data and centralizing as little data as makes sense relative to your business problem.
Yeah, no, I want to get back to that, but let's finish off. Okay, the requirements side. So we have got the requirements to hold the data. We've got the requirements to support the analytics package, software. What else? Are there any other requirements that we're looking at?
Sure, there's one more step. There's integrating the insights of that data into your business process, right? We're not housing this data just to house it. We want to do something with it and create value. Right. At the end of the day, you probably don't want to just generate a report. You want to have a meaningful impact. You save on costs or increase revenue. In some cases, increase things like patient safety and remote, patient monitoring. So that requires a level of integration. Sometimes that's integration work through an SI. Sometimes that's a set of connectors that some vendors may have that provides application level integration. There's a number of ways to do that, but there's always some sort of integration component into the business process that you're really trying to support.
So if we're looking at it from the other perspective, and really that's the purpose, of our conversation, is to help our listeners. Our listeners are going to be the folks that are going to be buying these solutions. So you're saying then integration is an important part. If we reverse engineer that and look at it from the other way, okay, so if they're getting an analytics system, what are they looking for in particular to make sure that they can do this integration with, I guess, as minimal cost and heartache as possible?
Oftentimes, it's looking for a platform with either connectors that are defined, and that's more of an older model for application integration. These days, it's things with platforms that have a well-formed REST API set where you can do application-to-application integration. Sometimes it is embedding components of another platform. You can have an analytics system that provides some level of visualization and process flow widgets that you can embed into your own application that's custom or within another business application. So there's a number of ways to do that, but connectors are going the way of the dinosaur a little bit. But having well-defined REST APIs or embeddable components seem to be the way to go these days.
Oh, good advice. So if we generalize this for getting data in and out, is it the same advice, looking more for a RESTful based interface rather than the older connectors model?
Sometimes it depends on the data volume, but what I'll say is even within the IoT, ETL is alive and well.
Okay.
Couple of things, when the things that I see, especially with early stage customers, they've implemented a data lake knowing they're going to want to derive value from the data in the data lake at some point, and they're afraid to throw anything away. So they're kind of hoarders.
Gets bigger and bigger.
They're hoarders in that regard. and they're like, okay, I've got data and I've solved my connect and collect problem. Now I need to go do something with it. And normally they're not transforming that. They're just depositing data.
No.
So ETL is alive and well in a couple of respects. One is, extracting, transforming, and loading that data into something a little bit more consumable by an analytic system. And then there's oftentimes online ETL. So as data is coming in, you want to do the transformation and loading in a way that you can make that data more useful to your analytics and applications. And that's done more in real time or streaming. So ETL is still alive and well. Sometimes you're just throwing data into a data store, but oftentimes you are transforming it and loading it in real time, or doing after that data has been at rest for a while and you figured out what to do with it.
Explain ETL a little bit more for our listeners.
Sure. So ETL is a process of moving data around and doing something with it in a way that's a little bit more consumable. It stands for extract, transform, and load. It's a term that has been coined for some time in more of the data mart, data warehousing movement, where you needed to extract data from either a raw data source into a data warehouse, making it much more usable for applications that sit on top of the warehouse, which is the transformation part. The loading is just data movement. So extracting it from one place, transforming it in a way that it's consumable to an application, and loading it to another place to make it available to those applications.
Okay, and what does that mean? What am I buying to do this? What am I spending money on?
You're spending money on something like, from a vendor perspective, something like Pentaho from Hitachi Data Systems. So it's a software solution set that can sometimes be combined in an overall suite. A lot of ETL tools that were standalone historically have been consumed in suites, by large vendors like an IBM, a Teradata, or an Oracle. There are some of these vendors that have their products out there, or in some of the emerging IoT platforms, it's functionality built in. But the do-it-yourselfers in some cases, or some of the large installations that have very unique requirements based on the applications that need to integrate with the data, they are using separate tools as well.
Okay, so the ETL, I think what you're saying, this could potentially be an important part of your shopping list, and if it's not on your platform vendors, if it's not part of your platform vendors toolkit, then you may need to look at this as a bolt-on and integrating it so that you can make use of these these large pools of data.
Yeah,
is what you're saying.
It's definitely on your evaluation list.
Right.
Yeah, and if it's not in your platform, or at least functionality that talks about moving data around it and making it available to other applications in a more consumable form, then definitely put it on your list to go find out more.
Okay. So still on the topic of getting data in and out, is there anything else? I mean, we've talked about different interfaces now. We've talked about ETL. Is there anything else to consider?
I think that's mostly
Okay.
kind of the in and out versus the out is attached to what you do with it, but I think we'll dive into that a little bit more later.
Yeah, yeah. All right. So now I want to talk about you kind of alluded to it. Well, we've been alluding to different parts of it for a while during the whole conversation, but man, you can if you're generating terabytes of data, per minute, per second, per hour, I don't care, whatever. It's a lot of data, and I don't know exactly what the stat was that I recently read, but given the stat is something north of 70 to 75 to 80, I can't remember what it was, percent of data is not even looked at after you've stored it. Let's talk about this distribution of analytics, and specifically, you mentioned fog. I've also heard of swarm computing, where it's actually not just on a gateway that, say, a Cisco sells, but even closer, right into circuitry of the sensor itself. But want you describe for our listeners kind of just in general the distribution, the pros and cons, and what the state of the art is today for analytics.
Yeah, that's a great question. The place where the person who's looking at this normally goes is they go with what they knew, which is it needs to get centralized somewhere, either in the cloud or my data center. So I think, the traditional BI and advanced analytics types of solutions, that helps me solve oftentimes very strategic problems, like things that take, days, weeks, months to make decisions about, like, what do I do with my product lines? Do I have to do something to match capacity of my production line with, macroeconomic data as well as production data, from the floor. That's what a centralized location is often really good for when you have to make those corporate-wide decisions based on all of the data sources.
Yeah, like you were saying, it's sort of related to the past. So it's something that you've stored, and then at a point later in time, you're going to look at this information in the past.
Right. And it's a great data in motion use case for analytics in the cloud, or excuse me, data at rest.
Data at rest. Yeah.
Now,
okay.
As you get closer to the edge, this is where the state of the art starts to come into play, because we've lived in this centralized world from the databases we've been talking about, and now processing is getting more distributed. So as you move out into the fog, the types of analytics that we see in the market today are things that are happening in more real time. So whether you have something like a complex event processor, which its whole meaning in life is to take data at a very fast rate, perform some analytics on it, weed out what's important, and then take some kind of action on it. Sometimes that's at the front end of a cloud-based application, but we're seeing that kind of technology move beyond the boundaries of the data center or the cloud closer to the edge. So there's a class of technology that's running on things like a gateway, as you mentioned, from Cisco, where they're taking a look at things that are occurring in real time, but sometimes it's very simplistic in its nature. So it's a rule-based system that says, if temperature is rising and pressure is falling, that's something that seems very unusual. Could be an overheating situation on like an oil well. Go do this action. And that's a very simplistic way of performing some analytics and rules-based. Can be hard to maintain, but the state of the artness of it, for lack of a better term, is the fact that that's getting pushed close to the edge.
Yeah. And wouldn't that also filter the data too, in the sense of, if the temperatures go up and the pressure is dropping, I think that's what you said, then maybe save this data, as opposed to if it's not, then it's just same old same. I don't really need it.
Yeah, and that is actually a common strategy for reducing the data that has to be moved. So perform some local analytics. Don't move all of the raw data, the insights that you believe are actionable. Sometimes that's a good thing. Sometimes that can be a challenge, because you are throwing away data you might otherwise gain some insights from. And I call that actually data blind spots and the types of problems that you may want to solve.
Wait, I thought you were calling that data hoarding.
Well, data hoarding was keeping everything in a data lake, not knowing what you're going to do.
Okay.
And bumping into it on your way to your office, because it's, make data, your storage systems grow fat and outside the boundaries of the doorways.
Yeah, you're embarrassed to have customers over. I mean, because you got data laying everywhere.
Exactly.
You look at your shoes when they come in, and all right.
Yeah,
okay.
But the idea being, I'm not suggesting that we should store all data. If in a perfect world, that would be great. but there are practicalities to doing that. But the ability to perhaps store more data on the edge, and there are very cost-effective types of emerging technologies to store this on lower cost hardware. And that's a lot of what vendors like Cisco are trying to figure out, just because they want to be able to provide more insights from all this great data instead of filtering out 99% of it where it could be actionable. The stat that you gave is right. It's around 70 or 80% of data is never looked at, and that's one category of problem. Doesn't mean it's valuable. It might mean that we don't have the analytic systems in place to derive value from that data fast enough, so we choose to focus on the things that are low-hanging fruit.
Yeah, I think that's right. I think the other thing is just we don't know what the hell to do with the data. But I want to go back to something you perked my attention was storage. So I was thinking processing on the edge, and you're saying storage on the edge as well. So I think I know where you're going with this, but explain why are you storing anything on the edge?
So there is definitely a processing element, but from a storage perspective, if you're performing some of that rule-based analytics I was talking about, and you're storing data away, and that gets to what I call a data blind spot. But some of those edge situations where you are trying to say do something that's more advanced in learning with like machine learning and advanced analytics. Yeah. When you create a predictive model, the more data you have, the better your results. And that requires a need to have data that's stored for some amount of time to strengthen the value of that model in machine learning over time. So there are use cases where that becomes very interesting. And as I mentioned, this is pretty new to get machine learning out to the edge. There's all different kinds of classes from simple to more advanced from a runtime perspective, but the learning aspect, which is a world that I live a lot in and pay close attention to, the learning aspect out on the edge is something that's, again, that's a little bit more rocket science these days, but a number of vendors are trying to solve that problem for the very reason that you might be losing out on learning from that data that you're throwing away instead of just performing something that you're already looking for.
Well, I'm a bit confused because why not then, if you're going to be doing this predictive analytics, we'll just use that as a class of analytics solutions that you're going to apply to your data. Why not just store it in this lake and do it there? Why store it out on the edge?
Because the cost of housing all that data and keeping it over time, it's not manageable. And when I say cost, it's not the cost of just software. If you think about what it takes to power and cool a data center, you're spending even on cheap disk, but in terms of many terabytes, that gets extremely expensive, even if you're going cheap and deep storage, and you're not worried about all the software that can handle redundancy and backup and failover and all that kind of good stuff. So distributing that out actually presents a cost advantage if you can find an equation that says the hardware that's required on the edge with the levels of redundancy and resiliency that you need, as it makes sense, which that's part of what's emerging as well. We're not there yet, but that's part of what's emerging to enable closer processing to the edge. The other element is just the timeliness of it. There is still going to be data transmission costs that's going to limit the amount of data that practically will get centralized.
Yeah, assuming then that type of routine needs to be done in a near real-time or real-time basis. But yeah, okay, that kind of surprised me. What I thought you were going to say was to basically use the edge memory as a buffer, and then keep it until you don't want to throw it away, and then throw it away. I thought that's where you're going with this, actually.
Well, that is what's going on today to some degree, right? So there's certain levels of where the innovation is happening and where we're mainstream. Today, we're out on the edge. It's basic analytics in the form that I talked about. The next step is doing some level of caching or buffering to take a look at that data. But that's usually for analytics that's on a reporting nature or doing a analysis.
Okay.
there's kind of the advanced class, which is the predictive models that can run out on the edge, which you end up having to create those models usually centrally, but deploy them out on the edge. So that's another
Yes.
class. And then there is the kind of nirvana state that I'll talk about. If you can push the learning aspect of advanced analytics to the edge as well, there's going to be, you're going to lose or you're going to gain efficiencies by avoiding the data blind spot. And you still have the opportunity to affect a certain number of use cases out on the edge in real time. I'm not suggesting for the IoT you need this for every use case, because you don't, right? There are some decisions that you can make with data that's centralized at rest in the cloud or your data center.
Okay. Steve, explain the data blind spot to me again, because maybe I missed it the first time, but because, yeah, it's not the same as hoarding it just so you don't lose anything. You're implying that something different. Can you explain what is data? What do you mean by data blind spots?
What I mean by data blind spot is, let me go back to the smart parking example. So
Yep.
you have about 70K a minute. And because of data transmission costs for municipalities, they often want to make sure they filter that data out and get it to, say less than 10, maybe even closer to 1. But the problem that they've chosen to try to solve with that data is something that's very specific. Help me understand the duration of parking of vehicles in a parking lot. And then if I can connect that intelligence with some smart signage, I can direct, traffic to places where there's availability. That's a very specific problem that they're trying to solve. Now, what they are losing in terms of a data blind spot is when they collect the data, they're losing the ability to mine that to find other opportunities for other problems to solve.
Got it.
So when you're looking for something, it's very easy to look for something that you're looking for. But that's the great thing about data, and especially with analytics and varying types of advanced analytics, you might find things in your data that create opportunities either to solve new problems or even create new lines of revenue, depending on what your business is.
Absolutely. So that leads us to our hoarding then.
It does, but I think I'm gonna regret bringing up the word hoarding, but that's actually data hoarding is a great word.
I like it.
But again, the challenge with that is simply the cost of storing everything.
Yeah.
And so you could argue with that term that there's a potential opportunity to do distributed hoarding by pushing it out to more of a distributed set of storage out on the edge. We're seeing the processing happen out on the edge, and in some cases even on device, and in extreme cases even on chip. But I think you're going to see the same thing with data, because the more value you can derive closer to the edge, you're going to minimize the cost of storing all of that data centrally.
Yeah. No, and the hoarding, I guess I just bring it up in the sense of it seems like there's a balance, because you're balancing the cost of storing this data versus the potential value that you may find in the future if you were to apply, if you were to come up with an idea and then or discover this idea with some form of analytics. And that's kind of the balance that it sounds that we're talking about here, isn't it?
It is. And then there's one more element. I can't tell you how many times I've spoken to some of my customers and partners that say, I want to solve this other problem. And I ask them, well, do you have any data? Well, no, I've thrown 90% of it away, but I sure would like to solve that problem. We can't even begin to figure out if we can answer that problem with any of the data if it's not retained.
So what's your advice then?
The advice is to there's a couple of things we can do today. One is to the point we've talked about earlier. Even with all the data that we have, it's difficult to analyze that. Yeah. So it's really, you have to take a stepwise process. You absolutely do have to say there are certain problems that I want to solve. Let's make sure we can solve those problems with our architecture and adjust it otherwise. One of the things that I'm seeing, which happens to have a lot to do with where I work now at Predixion, is we're seeing a class of problems that have a lot of difficulty being solved out on the edge because we simply can't perform the analytics, less so the storage of the data. So I think that's the next step. So you do. I'm a very practical, technologist and marketing person. I like the idea of technology applied to problems that can be solved in a cost-effective way. I'm not suggesting everybody go try to figure out how to get a large database on an internet gateway that has the processing power of a 1996 Pentium. That's not going to happen. It'll happen someday, but we have to get the storage associated with it. So be pragmatic with the problems you want to solve. Figure out the things that you can solve with the data that you have today, but don't necessarily lock yourself into an architecture that doesn't allow you the flexibility to perform the analytics out on the edge for the problems you're solving today, and provides a pathway to be able to do more on the edge from both the data collection and data analysis, along with the real-time aspects of performing the analytics out on the edge that helps you take action on things in real time.
So give me some examples of the value of performing analytics on the edge.
Sure. So a great example is I was having a customer conversation around a concept of smart mining, and everything's smarter connected, but I have smart mining. The example was in an open strip mine. You have these large Caterpillar machines, these just enormous earth movers. You've seen pictures, right? People standing beside a
bucket wheel excavators.
Exactly.
They're huge.
So you see a guy standing beside a tire, and the tire is twice as tall as he is. Those are extremely expensive assets. So being able to perform predictions out on the edge, if you can take a look at the sensors that are all connected within one of those vehicles, and you can predict the likelihood of an engine failure within, say, a 30-minute or an hour time frame, what you can do is you can take that vehicle out of service. Now, that might sound like not a big deal, but let me describe to you the downstream impact of one of those vehicles breaking down. In open strip mines, you have enough room for one vehicle to pass. The reality is there are probably 5 of these trucks lined up one by one. So if one in the front breaks down, you can't put anything in the 5 behind it, and you certainly can't move it. On top of that, the other really expensive Caterpillar earth mover who's filling that truck up, it has to stop or it has to move, and you're losing valuable production time. If you have 5 trucks that can't get filled, you may also have to stop your drilling. This has a very significant impact. And when I was talking to the customer about this, he said, yeah, we figured out that the truck broke down or was about to break down, but it took 2 weeks for us to figure that out because it took that long for that data to get to our cloud.
Okay. I mean, that seems pretty slow, right? I mean, because I was going to ask you, my next question was going to be, why can't you just do this offline, or is the window for predicting this catastrophe less than I guess an hour or something like that?
Yeah, the great opportunity with the IoT is things in remote areas can get connected. The challenge.
Okay.
The challenge with the IoT is still there is the fact that you can operate locally disconnected, and because of the bandwidth costs, you may not move data to the cloud except for once a day, once every couple of weeks. So being able to take something, being able to take that truck out of the line so the rest of the trucks can keep moving, while there's an expense to that, it's not as bad as it breaking down and holding up the entire mining operation.
But more in particular to the question, what you're saying is if the truck is not connected in a period of time required to do the predictive analytics on it, then you need to do it locally because you're not connected, and hence the savings that you were talking about.
Exactly, and you can interact with the driver on the head unit in the vehicle or at the field manager level. He's sitting in a trailer on the mining operation site, and that's all. That's all locally connected. Getting to the cloud is a different thing altogether in an open strip mine.
Okay, all right. What are some important things to consider when you're buying an analytics system? Then we've talked about a few of them, but take me through at a high level. I mean, what are some best practices that you've seen here, in particular when considering the purchase of an analytics system?
So the undertaking of an IoT project is not necessarily for the faint of heart.
Nope.
If you're starting from scratch, there are quite a few elements that you need to consider. So as with any project that is of that ilk, you really have to be really clear on your objectives. Like the case where I've talked to customers where they've been collecting data That's a bit of an outlier, but there's more of those than I thought that I would see. But the reality is there's an expense to that somebody might have to answer for. And we often don't have the luxury of doing that. So you have to be really clear on your objectives.
Okay.
Sometimes it is something as simple as reducing costs, but understanding the types of problems you may want to solve in the future are really important, because within the IoT and things like mining or manufacturing or various industrial use cases, those types of businesses want to install infrastructure and not touch it for 10 years.
Sure.
IoT is not actually changing that, right? We're not getting into lengthy cycles because a lot of the smarts are embedded in the thing. So on the production line, they're not getting changed out. Now there's great opportunity with interchangeable units, but manufacturing organizations or even utilities, they have a tendency, while they were early adopters of M2M, it was for a very specific siloed reason. They're a little, it takes a little while to get them to move into a more flexible architecture that can be plug and play. So get your objectives straight so you have the right solution for what you need at the time, but also consider that you need the flexibility to grow, because the value of the sensors are going to present you with opportunities that you're going to want to solve, question after question after question, and to the point of you're going to find gold in that data if you keep it at some point. Mm-hmm. You always have to balance that with the practicality of the expense of the problem you're trying to solve. Just make sure you have a flexible architecture so you can grow.
What does that mean?
That often means making sure you're working with a set of sensors. Everything, it's popular to talk about software defined, but a lot of things that are software driven, like the rise of the IoT platform, to me is very much specialized applications built on more traditional middleware architectures. So making sure you have a platform from a software perspective that helps you build the applications to solve the problems you want to solve, either ones that you're building yourself or working with a solutions partner to figure out. It's really important to have a flexible architecture. The other is making sure you have in mind a way to evolve your data movement from the edge, the architecture of moving your data from the edge into wherever you're going to move it to, whether that's direct to cloud today over cellular or even satellite still in these cases. Making sure that you can move to maybe a gateway architecture. So that's a lot around vendor collection, understanding the implications of negotiating long-term contracts with bandwidth carriers and service providers. And then ultimately, if you choose something like a more packaged system with a platform, just make sure you have the room to grow, right? So make sure you have the ability to expand the capacity. If you really do want to hoard the data and you have the luxury of being able to do so, make sure you have the available capacity either in your solution or the cloud to do that. And if you really want to get, to the cutting edge of what people are doing today, understand if you can move the analytics capability both from an execution perspective and an analysis perspective for those real-time use cases out on the edge.
Okay. So make sure you're clear on your objectives. So to me, that talks to planning. So obviously you need to plan this out in advance, which of course I'm a big proponent of. Flexibility, I think I understand that a little bit more, and I think that comes down to specifically, again, something that's near and dear to my heart is basically being able to iterate on your software-defined product on the application and the model that you're building. Are there any other things to consider when you're buying an analytics system?
Well, we can never get away from cost, right? So
let's talk about that.
None of us have a blank checkbook, which would be awesome if I had one or my customers had one. Either way, I'd take one.
Sure.
But that's just not the world that we live in. And sometimes when we're making economically sound choices, that can create a bit of a haze over the flexibility item that I brought up before. But it takes a little bit of patience to balance your pricing objectives with a solution that can help you grow in the future. But with the trend in the market today, everybody knows that they need to go there, right? The proprietary systems of the past are, they have a shelf life, and we have to be open and expandable and flexible, and we know that. But making sure you're really clear that you take all the cost elements into place. There's a difference between a greenfield IoT deployment where you're going from sensor to communication to collection allocation and analysis and applications from, there are these classes of devices that have sensors on them today, but were never connected. So there's a different way of looking at your budgets from getting connected to collecting data than analyzing it. And so you just have to make sure you take a look at all the costs and make sure you turn over all the rocks to get these things collected, connected, bring all that data in so that you can analyze it and build meaningful applications to drive your business objectives that we talked about before.
All right, so let's talk about the costs. What are the costs? What do we need to consider?
So some of the biggest costs as it stands today are really around data bandwidth.
Okay.
So it's not unusual to see, particularly with cellular providers, right? There's this whole class of data plans that the average consumer who uses a cell phone, they don't see, right? There's a different set within the same cellular providers or through another business model called MVNOs who buy bandwidth capacity to serve for their enterprise and industrial type clients. But that's where the biggest expense is today, and that has a lot to do with the amount of data that people don't want to move, right? So they can save on the data bandwidth. So that can easily be thousands of dollars a month, and that's usually a monthly charge or hugely in annual terms. That's easily thousands of dollars. So understanding back to the practicalities, be practical to get success out of your project and the problem you want to solve, but don't back yourself into a plan that you can't get out of. But that's actually one of the biggest costs. The other costs that we talked about, or there was an implication to, is how do you house this data, right? Whether you're going to a cloud service provider, again, for large applications, for large users or large capacity requirements, that can easily get into thousands of dollars. And while time to value is often something that people take a look at when they're looking at cloud-based solutions, eventually over time they might run the numbers and think that there's a different way to do it. But as we talked about, if you really want to take advantage and build out your infrastructure, you're going to look at a subscription model cost where you can pay as you go versus a heavy CapEx where you're building out your own data center. Sure. And those can that easily turns into millions of dollars when we talk about the data capacities that we talk about.
You're saying to build your own?
Yeah, especially in your own data center, right? Housing that data. And then there's going to be, of course, the analytics software and other applications you might put on top of that data. And again, depending on the type of problem that you're trying to solve or application you're trying to build, a SaaS application that can turn into something as simple as, just a base analytical package on, a per user basis. That can be like super cheap, like, $1,000 a month. Or you can buy these, very large enterprise-oriented packages that usually are perpetually model license based, and those can go, hundreds of thousands to millions. But the other part of cost to consider is definitely, do you want a pay-as-you-go model or do you want a perpetual model? In some industries, with the way they run their business, they can amortize the cost of CapEx in the form of software upfront, and they like that model. Some like to go pay-as-you-go because it better fits the way their revenue model works.
Okay, yeah. So you're saying that, and this makes sense. You're saying there's three main costs: data bandwidth. That one, there's not too many options, and so to affect that cost, it's related to our earlier discussion with respect to how much data you're transferring for future consideration, housing costs, and we kind of have the rent or the buy kind of situation. And then the analytics itself, the cost of the analytics packages, again, you're saying that's a rent or buy business model. So the business model, those are the business models. Is there anything else that we need to think about?
I think that's pretty much it from how software is consumed. We're definitely seeing a trend for more of the subscription base versus, upfront cost. The other element is, of course, that we haven't talked about that's not directly related to analytics, but is a hot topic in IoT, which is security. Depending on the nature of that data, that may rule out certain types of public cloud providers. So it's also important to understand whatever regulations or policies around the data that you may be collecting will potentially necessitate one model over another.
Yeah, good point. Yeah. And just to get some ballpark, so you were saying data bandwidth. In your experience for the customers that you've seen, you're saying it could be thousands of dollars per month. You're saying housing is the same thing, thousands of dollars per month, and then you're saying it could be as low as I think you're saying $100 per user for a software as a service. For the software itself, for the analytics, are up to $100,000 to millions of dollars. But give me some averages. What do we, for what you could consider? I don't know what an average IoT deployment would be, but maybe just the average of what you've seen for those three costs. What are we looking at?
The numbers that I would know the best are really on the analytics packages, and those are mid six figures.
To buy
to buy even on a subscription level, right? There are those multi-million-dollar deals, and there's those smaller deals, but those have limited functionality. So it's not unusual to see mid six figures, especially in these large IoT deployments. That's probably a fairly accurate average cost.
So $500,000 per what?
That's usually an aggregate. So most of the pricing models that are out there within the IoT try to price by device. So there's some value-based pricing metric, and sometimes traditional analytics, it's been size of data that's now transferred in the IoT to number of devices or things that you're analyzing. Sometimes there, are more generalized costs for flexibility. There's a lot of flexible models, but the trend is definitely to go to some value-oriented model around the number of devices that you're performing your analytics on.
Okay, no, I get that, but just to understand the 500,000, even if it's an aggregate number, is that $500,000 a month, $500,000 a year? Is it one time?
No, that's usually on a yearly basis.
On a yearly basis.
I don't think anybody would be making money.
Yeah. Well, I mean, you're kind of freaking me out even with that number, to be honest with you. $500,000 a year, but you must be talking about pretty big deployments.
Yeah, those are very large deployments. And
very large.
Average,
okay.
Anywhere from a quarter of that, so 250 to 500. I would say is average for the larger deployments.
For the larger, okay.
Yeah, and we are seeing, when somebody's solving a problem today within the IoT, they're usually solving a big problem. I think as with everything, those costs obviously will come down, and there'll be different ways to solve different kinds of problems for smaller deployments.
Yeah, it makes sense. Awesome, Steve. I appreciate it. This has been really enlightening for me. Where can people find out more about you and your company and what you guys are doing?
Sure. The best place to find us is on our website. So that is predictionsoftware.com. We also have...
With an X, but I'll put that in the show analysis notes.
Thank you. I've been here long enough.
It's not Predixion. It's Prediction. Yes.
Thank you for pointing that out. So a lot of great information on our website there, but you can also go to YouTube and do a search on Predixion with an X. And you'll see a large number of demos, samples, tutorials, talks by a number of our, industry luminaries and our company leaders about what we're doing in the space and advanced analytics. So our website and YouTube, that's the best place to get started.
All right. Well, I'll put both of those addresses in the show analysis notes. Thanks, Steve. That was good. You opened my eyes to a number of things, and I think I see a reality show, The Data Hoarders, coming to a screen someday near you or sometime near you.
You never know. That might be our second career. We can go co-produce it. I appreciate it, Bruce. It was a great talk.
Thanks. Bye.
Right, bye now.
All right, man. We didn't get into a couple of the questions because, I think that was awesome. I think you took us in a bunch of places, kind of some of the nooks and crannies that most folks don't have a light on. So that was good. Did you feel okay with it?
Oh yeah, it was good stuff. I'm okay with not hitting all the questions. I like the flow of digging into answering questions on a deeper level. So yeah, that was good. Good.
So where do you live? You said you were referring to I think you said the Redmond office. Where do you actually physically live?
I physically live on a plane. I actually live in North Carolina. Our
Okay.
headquarters are in California, but our primary engineering office is in Redmond.
And what are you doing in North Carolina then?
It's a long story. I came to know Predixion through former coworkers and have relationships with one of the board members. So on my journey of the things that I wanted to do, I spent a lot of time figuring out what I was going to do next, and
Yeah.
it took me a while to settle on Predixion. But it would have been absolutely perfect if they were located in North Carolina. But I've worked remote for the better part of, I don't know, the last 12, 13 years.
So you knew where you wanted to live, then you just had to fit the job into where you lived then. Yeah. So you like it there then?
I do. I honestly thought that my career or job would make me move, but I've been there for about 20 years and it hasn't happened yet.
Yeah. So as long as you're okay with the, man, so I went through a big part of my career. I was like this 100,000-mile guy, and I was Air Canada. So Air Canada is awesome, right? So that's when I was living in Canada. Literally, we just moved here 5 years ago from Canada after 13 years. But then I didn't travel. Then I was doing this gig, growing it, no need to travel. And now I'm starting to travel again. And oh man, I'm not digging it at all. I mean, unless you're someone like you that have a lot of miles, like I just booked the flight to New York just yesterday. And holy crap, looking, now you can see the seats and all that and what's available at different prices. It's just horrible, man. Nothing. I mean, it's just horrible.
Well, I try to stay under 100,000 miles, and I'm lifetime gold on American. So I hit, I hit 1 million miles.
Wow. Yeah. That stays with you too. Is an American the one that stays with you? I can't remember. One of them stays with you no matter what happens. You don't have to keep flying and flying.
It's American, so I'm lifetime gold. I don't want to get to lifetime platinum, but I did a similar thing. I worked for Red Hat, which was local, did that for a couple of years, and it was good. It didn't work out for me in the type of job that I wanted, so I'm working remote again. But it's not that I look for jobs that are remote. It's just the things that seem to excite me in the places where I have relationships and can do the things I want to do have a tendency to be in California or somewhere else.
Yeah. No. Don't get me wrong. I mean, I enjoy it too. It's just, I think if you're not someone that travels a lot, I think there's the world for the people that travel a lot, and then there's the world for the people that don't. For the people that don't, man, it's not a pretty world. That's all I'm saying. For the people that do, it's nice. I mean, you got the lounges, you got you get the pre-boarding. Generally I was getting upgraded all the time, so life was good. But now I'm not that. So I'm like with the unwashed masses, man, and it's not pretty.
Yeah.
So that's all I'm saying. It's just really changed in the 5 years that I've I guess it's only been 3 years, but whatever. But still, anyway.
It feels like 5. That's fun.
Yeah. All right. Well, thanks a lot. I appreciate the short notice. This podcast is going to be up next week, and it's really growing quickly. So yeah, you're going to literally get thousands and thousands of listens the first week, and then it'll reach the 10,000 mark probably in week 2 or 3. But it's But yeah, no, it's good, and I appreciate your time and your flexibility to do this in a short notice.
No worries, I appreciate the opportunity.
All right, Steve. So we'll catch you later,
Great.
huh?
Thanks, Bruce.
Okay, that was a real good talk with Steve Stover of Predixion Software. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is a panel called IoT Platform Security, Sensors, and Analytics. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a balanced one.
You have been listening to the IoT Inc. Business Show.